All right, section 3.1, we're going to be learning about exponential functions and their graphs. So the exponential function f with base a is denoted by this. So it's still a function, so we still have f of x, which is just a fancy way of saying y. And then x is in our exponent. So this is when our exponent has the variable, and a is just our base. A cannot be 0. Well, a has to be greater than 0, and it cannot be 1. Because if we had 1 to the power of x, it's always just 1, no matter what our exponent is. So example 1 says evaluate the function at the indicated value of x. Round your answers to 3 decimal places. So for these, we're just putting it in our calculator. If you have a calculator, you would put 0.5 or just 0.5, and then there's a little caret button that looks like this, so you click that button, and then 1.2, and then you probably have to click enter equals. If you're putting it in the phone calculator, you would do 0.5, and then there's a button that says x to the power of y, so you click that button, and then 1.2, and then equals, and it should evaluate it for you. So it says round to 3 decimal places, so this would be 0.435. For B, we do the same thing. So just put it in our calculator, it would be 150 times 2 to the power of negative 2.5. So we have to evaluate our exponent first. So remember PEMDAS, got to do the exponent first. So I would say 2. Then x raised to the power of y, and then negative 2.5 in my calculator. So when we put this in our calculator, we should get 0.17677. I'm going to keep as many decimals as I can if I write it down, but I'm just going to keep it in the calculator and multiply it by 150 as the last step. So when we times this by 150, you should get 26.5165. The fourth decimal tells us how we round. So since 5 tells us we round up, we round the 6 up to a 7. So this means we round up. So it'd be 26.517. So for these, you're just putting it in the calculator. It's important for these types of questions to know how to use your calculator, especially when we get to questions later on in this section. You gotta know how to use your calculator and what to put in first. So here we have all of the characteristics of just a basic exponential function. So just when we have a regular number, whatever our base may be, to the power of x. So our domain, no matter what our base is always all real numbers from negative infinity to infinity. So the domain is all real numbers. Always. Our range, so from the same bullet point, the range consists of all positive real numbers. So if we look at our graph never crosses the x-axis, so it's always from 0 to infinity because it goes up forever. So range is y values. Y values aren't going to be less than 0 unless we have a shift, but we're just talking about our basic exponential graph here. So when you have shifts or transformations, shifts can change this. So we're just talking about the basic, any base to the power of x. If I had a shift somewhere along the way, which we'll talk about shifts in a couple of slides, then these characteristics will change. The y-intercept of our graph is 1, because if I plug in 0 for x, no matter what the number is, if I had 4 to the power of 0, this would be 1. So any exponent, any base to the power of 0 would make your answer 1. So our y-intercept is 1, again, unless we have a shift change. If our b is greater than 1, so if the base is bigger than 1, we have a graph that goes up and to the right, so it's increasing. If our base is in between 0 and 1, so it's going to be either a decimal or a fraction, because it's not going to be negative, because we know that our base has to be greater than 0, but it'll be something in between 0 and 1, so some type of fraction or decimal, then our graph would be decreasing. And then lastly, let's look at number 6. It says the graph of f of x is equal to b approaches but does not touch the x-axis. The x-axis, or y equals 0, is a horizontal asymptote. So we get really, really close to the horizontal line so that y is equal to 0, but we never touch. So that goes for increasing or decreasing. We get really, really close to the asymptote, but we're not going to cross it.
Example 2 says graph the exponential function. So we have two different exponential functions here, 3 to the power of x and 3 to the power of negative x. So to graph these, we want to plug in points and plot them. So I'm going to plug in values for x, get values for y, and that'll be our coordinate points, x comma y. And then we can graph. So some good numbers to plug in for x are always -1, 0, and 1. These are just the easiest numbers to evaluate, and it gives us a little bit of a range to see what our graph is going to do. We could plug in -2, 0, and 2. That would work too. But again, you just want to plug in some easy numbers so we can get the shape of the graph. So here I have 3 to the power of -1, which a negative exponent flips our number. We take the reciprocal of it, so that would be 1 over 3. So I plugged in -1 and got 1 over 3. So on my graph, I'm going to go to the left to -1 and up 1/3. Now I'm going to plug in 0, so 3 to the power of 0. Anything to the power of 0 is just 1, so I plugged in 0 and got 1. There's my second point, and I'm going to plug in 1. 3 to the power of 1 would be 3. So 1 comma 3 is my third point. So I'm going to go to the right one and up 3. If we wanted to keep plugging in points, we could, just to see the shape of our graph. But it's an exponential function, so it's going to go up super quick. And then we're going to get really, really close to 0, but never touch it. So our graph will look like this. Let's also find the domain and range of our graph. Domain is our x values. For exponential functions, it is always -infinity to infinity. And then our range, we start at our smallest y values and go up, and it's when our graph first touches. So our smallest y value here would be 0, but we don't touch 0 because 0 is actually our horizontal asymptote. So we could say our horizontal asymptote is y is equal to 0. And our range, again, our graph gets really, really close to 0 but never touches, so we have a parentheses 0 to infinity. Parentheses because we never touch 0. And then lastly, we can find the y-intercept. So y-intercept is when we plug in 0 for x. So here I plugged in 0 for x, which means my y-intercept would be 0, 1. We're going to do the same thing for our next graph. So we want to plug in values for x, get some values for y, and plot those points. So for x again, it's easiest to plug in -1, 0, and 1. Again, you can plug in other numbers if you want to. So I have 3 to the power of -1, which would make this a positive 1, and 3 to the first power is just 3. So I plugged in -1 and got 3. So on my graph, I'm going to go to the left to -1 and up 3. Next, I'm going to plug in 0. So 3 to the power of -0 would just be 3 to the power of 0, which is 1. Anything to the power of 0 is 1. So I plugged in 0 and got 1. So my next point would be stay at 0, go up 1. And then lastly, I'm going to plug in 1. So 3 to the power of -1. A negative exponent means that we have to take the reciprocal of 3. So instead of it being 3 over 1, it's now 1 over 3. So we just flip whatever number that is. So here, I plugged in 1 and got 1/3. So I'm going to go to the right one and up 1/3. Then I can connect my dots. So my graph gets really, really close to 0, but never touches, and it goes up exponentially quick. Again, we can find our domain, range, horizontal asymptote, and y-intercept. So horizontal asymptote is y is equal to 0. Unless our graph shifts up or down, that does not change. Our y-intercept is where we cross the y-axis, so where I plugged in 0 for x. So that would be 0, 1. I would say for the y-intercept, be careful on WebAssign. If it asks for a coordinate point, it'll give you the parentheses, so you leave it as a point, or sometimes it'll say y equals. So if it's y equals, it would be y equals 1. If it gives you the parentheses to put in a point, it would be 0, 1. So just be careful on which one WebAssign asks for. Next, we can find our domain and range. So our domain would be negative infinity to infinity. So it's all real numbers. And then our range, we're looking at the y values. So it's 0 to infinity. So our graph is going up. And it's getting really, really close to 0, but never touches. So that's why we put a parenthesis, because it does not include 0. For the next example, we're doing the same thing. We're graphing 1/4 to the power of x and 4 to the power of x. So just like we did before, we're going to plug in some points and graph. So I'm going to start with 1/4. So I'm going to plug in values for x, get values for y, and have some points. So just like before, it's going to be easiest to plug in -1, 0, and 1. So 1/4 to the power of -1. Negative exponent, we take the reciprocal, so that would be 4 over 1, or just 4 now. So I plugged in -1 and got 4. When I plug in 0, 1/4 to the power of 0 is 1. Anything to the power of 0 is 1, so 0, 1. And then when I plug in 1, that's just 1/4. So I plugged in 1 and got 1/4. So I'm going to go to the left 1 and up 4. Stay at 0, go up 1, and go to the right 1, up 1/4. And then I can connect my dots. With our graphs, unless we have a shift going up or down, we're not going to cross
Welcome to the Queen City.
y is equal to 0. So that's our horizontal asymptote.
As the nation.
So there's our graph for 1/4 to the power of x. Now we can do the same thing for 4 to the power of x. So I'm going to plug in values for x, get some values for y, and have my points. So I'm going to plug in -1, 0, and 1. 4 to the power of -1, we take the reciprocal of it, so that would be 1/4. So I plugged in -1 and got 1/4. 4 to the power of 0 is 1. Anything to the power of 0 is 1, so 0, 1. And then 4 to the power of 1 is 4, so 1, 4. So let's plot those points. I go to the left to -1, up 1/4. Stay at 0, go up 1, and to the right 1, up 4. Then connect my dots. Again, for this graph, our horizontal asymptote is y is equal to 0. So we get really, really close to 0, but don't touch. Our x-intercepts for both, y-intercepts where we cross the y-axis because we don't have an x-intercept. Our y-intercept is 0, 1 for both. That's where we plugged in 0. Our domain for both graphs are -infinity to infinity, and then our range is from 0 to infinity, just like we did before. With our fraction, because this is in between 0 and 1, this is a graph that has exponential decay, or it would be decreasing. so decreasing or decay. Since 4 is greater than 1, this is increasing, or we would say it has exponential growth. So here is the slide that talks about all of our transformations or shifts, as I've been calling them in the last couple examples. So we've seen this before. These transformations happen with any type of function. It could happen to a quadratic function where we have shifts there, anything like that, or an absolute value function. So you've seen this before in Algebra 2. When we are adding to the outside, so I'm adding something at the end of my function, that is a vertical translation. So that would move my graph up if I'm adding, or down if I'm subtracting. If I'm adding something directly to the x or subtracting directly to the x, that's a horizontal translation, so that would be to the left or right. So if I'm adding, we go to the left. If I'm subtracting, we go to the right. If I have a negative on the outside, that reflects the graph about the x-axis. So that would kind of change our domain and range. Well, the domain would stay the same, but it would change the range. So when we have transformations, our properties change a little bit. If I have a negative being applied directly to the x, we have a reflection on the y-axis. And then I also have vertical stretching when I multiply by a number, and horizontal stretching or shrinking when I multiply x by a number. The best way to figure out what's going on with these would just be to plug in points and plot them. For example 4, we're going to use the graph of f of x is equal to 4 to the power of x to obtain the graph of 4 to the power of x plus 3. And then we have to find the domain and range of both functions. So starting with our basic function here, I'm going to plug in points. We already did this 2 slides ago with the same numbers. So I'm going to do the same thing. If I plug in 0, I would get 1. When I plug in 1, I get 4. And if I plug in -1, I get 1/4. So that is our basic 4 to the power of x graph. Our domain and range of this function, domain would be all real numbers, so -infinity to infinity. And then the range, we don't have a shift up or down, so that would just be from 0 to infinity. So the range would only change if you had a shift up or down. Now let's graph 4 to the power of x plus 3. So this plus 3 on the outside means that we are going up 3. So again, we could make our graph, make our chart here, plug in values for x, get values for y, and plot our points. But we know using our transformations that when it's a plus 3 on the outside, we just shift all of our points up 3. So this point, instead of being 1/4, it's now going to be 3 and 1/4. So if I plug in -1, I'm going to have 3 and 1/4. When I plug in 0, so we'll plug in our points here just so we can see it worked out. So 4 to the power of -1 plus 3 would be 1/4 plus 3, which is just 3 and 1/4. When I plug in 0, I have 4 to the power of 0 plus 3. 4 to the power of 0 is 1. 1 plus 3 would be 4. So 0, 4 is my next point. So stay at 0, go up 4. And then lastly, I'm going to plug in 1. So I have 4 to the power of 1 plus 3, which would be 7. So I plugged in 1 and got 7. So all of my points just shifted up 3. 1 and 7 would be off our graph up here. And then I can connect the dots. So everything for my graph just shifted up 3. My domain for my new graph here is still negative infinity to infinity. However, my range changed because now my horizontal asymptote is here. So everything just went up 3. So now my graph gets really, really close to 3 but doesn't touch. So my range starts at 3 and goes to infinity. Be careful because a lot of people will look at this point and notice that it's at 4. And they'll say the range goes from 4 to infinity. But our graph only went up 3. So whatever we're adding here, that's the number that goes here. Same thing with our horizontal asymptote. It now got shifted up 3. So instead of y is equal to 0, it is y is equal to 3. In this example, we're doing the same thing. So again, we start with our basic 4 to the power of x graph. So we have 1/4, 1, and 4. That's my basic graph. Now when I subtract 2 directly to the x, that's going to shift our graph to the right. So we're going to the right too. So all of my points just get moved to the right too. So instead of being here, I go 1, 2, now I'm there. Instead of being here at 0, I go 1, 2, now I'm at 2. And then instead of being at 1, I go 1, 2, now I'm at 3. And then just connect my dots. Just like we did before, if we wanted to, we can plug in points for x, get points for y, and we would have our coordinates that we can plot. But we know that it's just going to take our 4 to the power of x graph and shift it to the right too. So just move it to the right too. For our domain, again, it is negative infinity to infinity. It doesn't change. For our range, our horizontal asymptote is still at y is equal to 0. We didn't go up or down. So my range is going to be at 0 to infinity, and my horizontal asymptote is y is equal to 0. So it's going to always repeat that number there. If the range changes, the horizontal asymptote changes, but that's only when we have a shift up or down. So here we just move to the right, so the range is still 0 to infinity, horizontal asymptote is still 0. This is where we're going to stop for part 1, and then we'll do the rest of the notes next week.